Hey guys, so today you and I are going to talk about testing. So let's get into it. So the question in question was, Frederick, do seasoned software engineers iteratively build small components in code which they test independently while building a large feature rather than writing all implementation and testing it at the end? I would say that the the really good software developers do that, but I wouldn't say that just because you have seniority you do this. It's down to me, this has very much to do with how well, like, sort of how talented you are as a software developer, uh, because it fundamentally comes down to how well you understand how to create good abstractions and how to segment things and deal with coupling within code. So an example would be usually when you have a mediocre software developer, someone might not be so good at software development. What usually happens is that they have a hard time thinking in terms of different logical segments. They have a hard time modeling a complex system in their head. So usually their abstractions become either very bloated, like you have really large superclasses, or you have really messy UI components that do too much, or things like that. Like they can't really figure out a way to deal with all the extra functionality, all the features, all the complexity, and so they're very limited in how granular they can be in their solutions. And what usually happens is, as I said, the complexity just continues growing, like on top of each other. Like it becomes an exponential growth in ugliness within the code. You see abstractions that really don't work so well, but the person lacks the talent to rethink the system or imagine how this could work, and so they just add to the complexity and try to, as I do like to say, they shim program. They try to just take what's ever there right now and continue building upon it, even if it's the wrong solution for the problem. They don't just recreate it because they simply lack usually the talent to do so. Or in some cases, of course, the problem is so big that they can't rewrite it and they're lazy. Like there are many ways. So you can argue for many cases here. What I, on the other hand, argue is that the software developers who become, as I call them, true seniors, the true masters of the software engineering, they have this ability, and they realize that they get very good at modeling their problems in a way, like mentally. They can mentally picture a feature into small and divide the feature into smaller components as you're describing. And this is what they usually do. They divide these problems into smaller segments and realize that here are all the players in my domain, and I need to segment them in this fashion because this keeps the code low. It has a loose coupling, and now I can test, basically divide and conquer. I can test each individual component. Whether or not they do it, like, they create that component first and then they write tests or so forth, there is a bit of a flavor there, because sometimes you have a problem that is so complicated that you start doing, I do this many times, in many cases, where I have a situation where, like, I have to do so much exploratory coding or reading up upon, like, basically trace the existing functionality within the system, that if I want to fix it, there's no way for me to foresee all the segments or all the different functions or modules that I'm going to need in order to make this thing happen. I know how to approach the problem, divide and conquer, but what I usually do is that I start dividing it up into smaller pieces where I know that we have different, like over here we have one component that's dealing with this part of the problem, there's another component that deals with that part, and so I create all the different components and segment them I try to, at the very least, in a fairly modular fashion. And then when I have a full picture of, right, this is how everything's going to fit together, I might write the test. Or in some cases it's a very cookie cutter problem, as we described here, where I realize that I only have to create, like, I have to break this thing into smaller pieces, and then I can just test that piece because I know exactly how that piece of functionality is going to work. It really depends on how complex the problem is. What I do see, on the other hand, is that the seasoned software developers, or, like, I don't really like that term because it just indicates to me it's sort of how many years have you been spending on this thing? And I've worked with many software developers now, guys, who have like 10-20 years of experience, who aren't really all that good at this, because and I truly believe that it basically comes down to how far you're going to further your education. I find that usually the software developers who never actually get into or get any good at writing unit tests or things like that, they're usually also very sucky at architecture. And the reason being because I argue is that when you become a mid-level software developer, you get to that magic moment, as I've talked about in other videos, where you are now good enough to keep a job. You are good enough to ship something and create a mediocre system or a mediocre solution. Basically, it's going to work, but it's probably not going to be a very elegant solution, or it's probably going to just be something there where it's going to require quite a hefty amount of maintenance. And usually software developers who are very weak in testing and writing unit tests and doing so in a clean and efficient way, they exhibit this problem. There's a lot of coaching I do with software developers like that, guys, like an enormous amount at this point. I usually in my last 3 or 4 roles, this has been one of the main thing that I've been hired to do. Basically, take over the entire. The companies have had teams with severe quality issues in the system, and they basically need someone to raise the entire quality. And that's something, I mean, even the QAs are shit at this. Honest to God, even the QAs are shit at this. I've never worked with a QA worth who could solve this problem, because it requires a person who understands that the quality of the system, it starts at the architecture level and works. Because if you have a shitty architecture, you're going to have problems writing tests, which means that you're not going to write any tests, which means that you're going to start having bugs and issues and regressions, which is going to lead to you adding more code, which is going to make the system even less testable, and the problem just snowballs on you. And that is the fundamental thing that the software developers I see, who usually are really good at writing tests and so forth, they are actually very good at architecture, system architecture. That's their secret, because they come to a point where they realize that if you want to have a really, really large problem and make it fairly simple, you have to divide it into smaller pieces, then test each individual piece, and then test the interactions between those pieces. The mediocre, like average software developers, they think in much bigger abstractions. Usually they have issues with architecture and modeling things in a way that is efficient, and that's just not, it can be everything from modeling data in an efficient way, or modeling a UI, or like thinking in terms of how do I segment different containers within my interfaces and things like that. That level of cognitive understanding of a problem, and being good at modeling and good at architecture, and then segmenting things with loose coupling, that's the thing that is a prerequisite for you to also be able to write efficient tests. Because if you can't do that efficiently, it becomes very painful to write tests, and the average software developer simply stops doing it instead. And this is why I argue that so many systems have usually very low unit test coverage, very low, in many cases, poor like quality control and reliability, etc., etc. It's a symptom of that issue, where you have software engineers who usually who basically lack the talent necessary to deal with an ever-growing problem where features just keep on piling up. And so because they can't divide and conquer efficiently and create smaller components that can fit together, they have a hard time with architecture. Basically, it leads to this problem, and you need someone to help them with that, because it's not something that they can work for 20 years, and that's not going to go away by itself, because it's a higher level of skill that is it's something that comes after you've learned how to just ship code. As I like to say, you first learn how to just get the thing working. Most people stay there, but if you want to make it work really well, especially dealing with complexity over time, you have to actually learn how to do that. And that is it's sort of like, and now you're talking about like master level understanding of designing software. So what I want you to take away from this is that I don't think that, personally, I don't see a lot of software developers do this to divide and conquer efficiently and test things independently. They should be doing that. That's the thing that they have to do in order to deal with an ever-growing code base. And if they're good, they will do that. On average, on the other hand, I say that the people who do this by default, they don't have to be told to do so, they're usually very good. Like, they're usually fairly senior experienced profiles, and they've usually dealt with system problems like this, and they've taken the time to get good at architecture, and usually that means that they're also very good at testing, because fundamentally your architecture has a direct correlation to your testing. If your tests are hard to write, your test is, again, like all of this stuff is, it's hard to maintain, and your quality is low within the system, it's very likely due to the fact that you have a poor architecture. Because with the bad architecture with system design, the complexity just keeps on adding up, and you just hack things on top of each other just to get the thing working. This is the norm in basically every software company I've ever been part of. But the people who can manage like a very stable, well-working system with high quality and testability and things like that, it's usually maintained by people who understand that. They've basically gone and become true seniors, as I like to refer to them. They understand not just how to make the thing work, they have understood how to make it work well. Have a great day.